Kubernetes and serverless. I'm Lockie Evenson, Principal Program Manager at Microsoft and CNCF Ambassador. I'll be moderating today's webinar, and we would love to welcome our presenters today, Mike Metral, Software Architect and Engineer at Pulumi, and Jason J. Smith, App Modernization Specialist at Google Cloud. Few housekeeping items before I hand it over to our prestigious speakers today. During the webinar, you're not able to talk as an attendee. There is a Q&A box at the bottom of your screen. Please feel free to drop your questions in there, and we'll get to as many at the end of this session as possible. This is an official webinar of the CNCF, and as such is subject to the CNCF Code of Conduct. Please do not add anything to the chat or questions that would be in violation of that Code of Conduct. Basically, please be respectful to all your fellow participants and presenters. Please also note that recordings and slides will be posted later today to the CNCF webinar page at www.cncf.io/webinars. And with that, I will hand it over to Mike and Jay to kick off today's presentation. Mike, you have the floor.
Great. Thank you, Lachlan. Welcome, folks, and thanks for having us. As Lachlan said, my name is Mike Metral, and I'm an architect and engineer at Pulumi. And with me is the prestigious Jay Smith, who's at Google Cloud working on app modernization. And today's talk is about taking production services into Kubernetes clusters and into serverless and seeing how you can mend the two across your team. A quick overview or outline of what we're going to be covering today are the following topics. We're going to do a brief overview of what the Pulumi tool is and how you can use it to manage your infrastructure. We'll use Pulumi to manage Kubernetes clusters and applications using real programming languages. We'll then jump off and do an overview of Knative and how serverless functions in the framework of Kubernetes. And then we'll cover serverless apps. I'll be covering the first two topics, and then Jay will be taking over with the last two topics. So we wanted to do a quick little survey just to get a gauge of the room in terms of the experience that you all may have, just so we can tailor the talk to make sure that everyone learns something today. So if you wouldn't mind visiting the URL at the top, it's just a simple visit of the URL. Go to polev.com/Mike Metral 075 and just select one of the options just so we can have an idea how long you've been working with Kubernetes. I have 2 questions queued up for you. So if you wouldn't mind participating, this would extremely be of use to us just so we can tailor the talk. Just to show what that looks like, let's see if we have any live participants who are joining us so we can see what the poll looks like. Again, just open up the poll tab. All right, great. We have 1 coming in. We'll give folks a couple more seconds. All right. It seems like we have a pretty good split where folks are definitely on the newer end for a third of it, and we have about a third that's been working with it for a while. So that's great. We have 1 more for you. So let me queue that one up. 1 more question. And let's go to that. How long have you been working with serverless? So let me queue up that poll real quick. So you should see the same URL. We have the other question. That is how long you've been working with serverless. Okay, so pretty interesting. We have it seems like a pretty good split on the Kubernetes beginners and experts, and it sounds like we have a lot of new folks to serverless. So thank you. Thank you for joining. This is an immense help for us. So let's go off and continue with the presentation. So what is Pulumi? Pulumi is a modern infrastructure as code tool. What that means is that you can use Pulumi to provision and manage cloud-native infrastructure using real programming languages. We support all of the major cloud providers as well as on-prem, and the languages we provide and support are JavaScript, TypeScript, Python, Go, and .NET. And why are languages important when you're managing your infrastructure? Well, for a couple of reasons. For one, as the industry has kind of shown, the appeal to mutating state on a machine is not the most declarative way to manage infrastructure. We've moved to a model where we're really trying to manage states in an API-based system. That's a little bit more programmatic. That's a little bit more tameable. And you can reconcile those differences pretty easily. That's very much how Kubernetes works. With languages, the real appeal to it is that as folks adopt their cloud native infrastructure, as operators and developers expand this architecture can become complex, and managing this really becomes unwieldy. So programming languages allow you to leverage the ability to have a full Turing complete machine, essentially, right? That allows you to use imperative code to drive declarative state. And this allows you to not only manage the complexity of your infrastructure, but it also allows you to technically change the properties and see those changes in your IDE, because we can code it against a actual spec. You can see helpers, you can see linters, you can see documentation, you can do testing. So using programming languages far exceeds how you can tame the complexity of your cloud native infrastructure than other tools in the current space. So how does that actually work? Well, let's look at the snippet on the right corner. What you see is Go code that allows us to import the libraries from Pulumi. So in Pulumi, we expose all of the cloud providers as well as Kubernetes as library packages that you import in the language of your choice. If I'm authoring Go, I pull down the Go modules from Pulumi's GitHub. In that, I can just then import the libraries, and I can define what I'm going to be creating and managing for my infrastructure. Here's a simple example. I'm standing up a firewall, setting up some basic ingress rules, and then I'm spinning up a VM with some basic properties on the machine type and the boot disk. I can also extract properties from the machine, for example, such as the IP of its NAT, so I can share that with other programs, or I can share that with other humans. So using code allows you to not only tame this, but you can actually leverage real symbolic referencing, right? When you want to orchestrate and assemble your cloud native infrastructure as it grows. Because we have code, you can share best practices using the package managers of your choice. So if I'm using TypeScript, I'm on NPM. If I'm using Python, I'm using pip. If I'm using Go, I'm using Go modules. If I'm on .NET, you're using NuGet. So all of these libraries to provision all of these resources across clouds and Kubernetes are exposed across all the languages that we support, and all you have to do is use the package manager that you already use today. With code, this allows you to integrate into your GitOps pipeline much easier, so you have a full audit of who changed what when. You can approve and change processes, because here you have essentially a plan of the infrastructure you want to build. You can preview that plan. You can reconcile or refresh the state depending on the back end to allow you to make sure that what is written in this program is the declarative state that we're always driving towards. But the infrastructure we have and the language support that we have isn't just for provisioning and managing infrastructure. You can also use programming languages to validate and test and unit test and integration testing on the infrastructure that you're standing up. So you can do things like make sure that a certain set of VMs with a load balancer come up with an HTTP 200, that a cluster that deploys a deployment or service comes up with an HTTP 200 endpoint on the applications. But that is just the beginning of how you can really embrace infrastructure and modern infrastructure as code using languages. Most importantly, Pulumi is open source. We're Apache 2 license based. We're free for community individuals, and we have great plans for SaaS and a SaaS for teams. But it's not just about cloud native infrastructure. Pulumi is really about enabling superpowers in Kubernetes, as we like to say, because you don't work with YAML, you don't work with JSON, you don't work with domain-specific languages. You use your favorite programming languages. So the same concepts that apply to cloud native infrastructure also apply to Kubernetes. So on the right, you'll see a snippet of a helper library that we created that allows you to create in 25 lines of code a namespace, a pod, a deployment, and a service using the TypeScript language. And this is a helper library we created that allows you to minimally describe what you need to, but we also expose all of the entire full API in Kubernetes as a library in the language of your choice. So the deployment specs match the spec that you expect. Same thing with services, same thing with config maps. We don't try to create new nouns and new verbs. We simply have a helper library if you so optionally choose to use it. But if that's not good enough, you can always drop down and use the raw API provider that you're used to using. So every API that you expect in Kubernetes is available as a library class in all of our languages. So you can declaratively describe your code. This allows you to do less copy and pasting. Again, we can preview these changes before they happen, see some rich updates. We can even deploy Helm charts. So it's not just about provisioning native API resources in Kubernetes. You can deploy Helm charts directly. You can deploy YAML manifests if that's something that you're trying to move away from. Because it's code, you can always set up classes, for example, that inject sidecars by default, like Envoy and Istio and others. And we have great integration points built in with all of our CI/CD partners. So let's show a quick demo. We're going to deploy a GKE cluster, an app, and then we'll show how you can use Helm chart to be deployed as well. So let me switch screens real quick. So here is my terminal. On the left is the program that I'm authoring. On the right is going to be some commands that I'm going to be essentially walking through the program. So the first thing I have, as you notice, this is the Python program. In Pulumi, I have a directory where I have the metadata file, pulumi.yaml, which just describes the runtime I'm going to be using. In this case, I'm going to be deploying a GKA cluster using Python. We have the requirements.txt, which if you've authored any Python program, this is exactly the same. So we just import the Pulumi libraries, and then we can actually use that. So before I jump into the code, let me deploy this on the right. Every program that you have can be instantiated, so you can parameterize different components of it. So we call those stacks. Stacks are an instance of a program. You can imagine that, why would you use a stack? Maybe I want to have different parameters for dev staging and prod, or different branches. So the first thing I'll do is I'll do a Pulumi stack, I'll do a virtual env, sorry, because I'm going to create a virtual environment since I'm in Python. Then I'm going to activate that virtual environment. Then I'm going to do a pip install of my requirements. As the requirements get stood up, just be another second. All right, great. And now we're going to do a stack init. So I'll do a Pulumi stack init. Again, this is an instantiation of the program on the left. We'll give it a name, dev. I'll set some properties like, because Pulumi has a built-in configuration management system that allows you to parameterize each stack. I'm going to set properties like which GCP project I want to be deploying into. I want to be using that one, the Pulumi development one. I can also set the zone that I'm going to be deploying into. With that all set, I can now do a Pulumi preview to see what changes I'm actually going to be seeing on the left. So let me go off and kick that off. I can see a rich diff if I wanted to. I can see a full diff of what's being created. As you can see, here's a deployment object, exactly as you would expect it if you're used to working with Kubernetes Manifest and the Kubernetes API system. So this is very fine-grained. Any of these properties that are immutable, Pulumi will surface to you and say that these can be changed or not, and we can update a resource holistically in a create before delete approach. So what I'll do that is after I've seen the preview, I'm going to kick off an update, say Pulumi up. Yes, I want to run that update. And we'll let that run for a couple of minutes, and we'll jump into the code so you can walk through that and see as this builds out. So the other thing to keep in mind is that here, since I'm using Python, I now have my IDE helping me in many different ways because I've been able to surface all of these APIs and all of these libraries really to allow me to integrate these specs with my IDE. So I'll get things like linting. Here I have an excessively long line. If I have typos in my spec, such as if I delete this letter, it'll complain to me and say, hey, this is not a formidable constructor call. It doesn't recognize this actual property. So we can definitely enforce typing of the specs that you would need to actually make sure you can deploy this correctly. So if you've ever deployed with anything with like APIs or templates, you tend to find out that you didn't discover these issues until after the fact. So seeing these things surface in the editor are great because it allows you to constructively work and iterate on your programs before you find out that you had a crazy syntax error somewhere down the line. So I have complete Python expressiveness here, right? I can tap into the configuration management system, or I can do defaults. I can set all these variables such as the node count, the machine type I'm going to be using, a username. We have a random entropy library that allows you to generate strong passwords based on dev random. And this allows you to not only generate machine-based passwords, but you can also rotate these. We can secure these because Pulumi has a built-in secrets management functionality. We can do things like ask for what master version you want to be running on your Kubernetes cluster. And then you can get to the actual definition in GKE of how a cluster is being stood up. So I can specify all of these parameters, right, and set them accordingly, set the OAuth types. And then I can actually construct a kubeconfig that allows me to leverage Gcloud, since I'm using GCP, to allow me to fetch and get a token that allows me to work with kubecontrol. But one neat thing about what Pulumi does is that it decouples the credentials from the infrastructure. And we do that by what's called a Kubernetes provider, or a provider for any cloud for that matter. So you can have a provider for GCP, for AWS, for DigitalOcean, for Azure. All of these are essentially ways so you can wrap credentials and decouple the credentials from the infrastructures themselves. So in case you want to swap clusters or deploy to multiple clusters, that has a good way to isolate that. And how we use that is simply below. So here we have a deployment spec. We're going to be deploying Nginx. Again, this should look very familiar to you if you've worked with a deployment in Kubernetes. It's the same spec. We don't alter it. We don't create new nouns. We don't create new verbs. You simply just have the ability to author this in the language of your choice. And we can pass this in. This deployment is a standard Nginx deployment with a replica by saying, use this given provider. So we can say, use these given credentials. Similarly, I'll do a Kubernetes service with a public load balancer. I'll have it use the same Kubernetes provider. And because I want to get properties of the stack, like say the kubeconfig, I want to be able to work with kubecontrol, I can export that kubeconfig by simply creating an export clause here and pointing it to the kubeconfig that we've defined up above. Great. Oh, and it looks like on the right, the cluster is up and the deployment and service is running, or it's being stood up. Let me actually zoom out that way so you can see that a little bit of that in progress. That's the other thing that Pulumi does. Like we can surface a lot of the information that you're seeing right to you in your CLI. So you can see as the pods are slowly starting to roll up and come up, you can see what's in the waiting state, where things are currently at with your infrastructure. So I'll give that another minute or two since the load balancers will take just a little bit left. Oh, we saw that the deployment's done and the service is the only thing that's remaining. Great. So in that, I can go one step further, and after the service is up, I can actually extract the IP of that load balancer so I can make that publicly exposable to another program in Pulumi or to a user. Great, so the stack is complete. I'm going to do a Pulumi stack output. So everything that you export gets put as an output. And so you can see that all the different outputs I have here are based on what I want to actually create. So I have the kubeconfig and I have an actual endpoint for the service. So if I do a get nodes. So I'm going to do a Pulumi stack output of the kubeconfig. I'm going to save that to a kubeconfig.json. We'll set up our environment variables, and then we'll just do a get nodes. Great, all of our nodes are ready. If I do a get pods, our pods should be up and running. Okay, cool. So this is a great example of how we were able to deploy. So if I do Pulumi stack output, if I curl this endpoint, ingress IP, so curl Pulumi stack output ingress IP, because I have this availability, 0. Oh, I'm using Python. It's just easier if I just do this real quick for the sake of time. If I curl this endpoint, it should just work. There we go. Okay, great. So we deployed a deployment in a service, and that's an app that we were able to show. But now we can show that we can also deploy a Helm chart. So here I have some code where I can also import from our Kubernetes library the Helm class. And let me hide these warnings because I don't have great linting on my wrapping, but I can see I can deploy the Nginx ingress chart simply by just defining this as you would expect it if I'm working with Helm, because the Helm support we have is for Helm fetch. So if I save that and I close my warnings and I run another update, let's see what a preview looks like, just to see what I'm going to be generating. It's going to deploy a Helm chart. Great. If I do a Pulumi up, that Helm chart will be coming up in a matter of seconds. So as that rolls out, you'll see that all of these resources get slowly created, and you'll see the same progress over and over again, just like we saw in deployment and service. So let's switch over to the slides again so we can continue on with the rest of the presentation. So we did a quick demo. I wanted to talk about how Pulumi works with many different tooling, right? So Pulumi is a tool for developers and operators. Not everyone uses the same tools. Not everyone uses the same platform. So we have many integration points with all of our source code providers that you would imagine, from GitHub to Atlassian to Visual Code Studio. You can use any language that we support, such as JavaScript, TypeScript, Python, Go, and .NET. Your applications can remain in the same language that they do. This is just about the infrastructure and how you manage it. We have many integration points with all of our CI/CD tools and partners, where we can work directly and drive the Pulumi CLI in each of these pipelines. And we have the ability to work with the package managers of the language of your choice. We support all the major cloud vendors on-prem and, as like I said, Kubernetes as well. On the bottom, you'll see screenshots of our console of how you can see previews in your PRs of what's going to change. You can approve that or deny that. You can see in the middle a screenshot of what our console looks like. You can have a complete audit of who changed what commit, what updates got rolled out, what was rejected. And then you can also see a fine-grained list of the resources, and you can actually jump to those resources in the provider of your choice. Just a little brief overview of how Pulumi works, right? So we the Pulumi service, don't see any of your credentials for your cloud providers, or any of the credentials that you have necessarily for your programs. What you do is you create your Pulumi program in the language of your choice. The Pulumi CLI essentially ingests that and will invoke a runtime depending on the language that you chose. And then that will directly make the API request on your behalf to the provider of your choice. There is no interchange format. There's no DSL in the middle. There's no JSON. There's no YAML. It is simply making an API request to the platform of your choice, where we are essentially working with the Pulumi SaaS, which is the ability. So you have to understand, this infrastructure creates a dependency graph, or what we call a state file, of the infrastructure and how that should be ordered to be stood up. We store that in our SaaS by default to do checkpointing on the state file to allow a distributed team to do concurrent locking so no one's stopping on changes. But more so, you can also leverage your own local backend system to store that file if you'd rather do that instead. How does the Pulumi program work? Well, as I showed, you have a program, you have some associated metadata, and the package dependencies that go into it. That's pretty much it. You can instantiate each of these programs as stacks. They're just divvying up the parameters really that you're going to be ingesting in each of these programs. And the main part about stacks is not just about instantiating programs, but stacks can reference other stacks. So if I'm, say, the networking team and Jay is the application developer team, I can create all of the infrastructure for the networking, say, in TypeScript on the left, and Jay can consume the IDs for the VPCs he should be using, or the IDs for the VMs he should be using, because I can expose those as outputs on my program for him to consume. So this makes it very powerful to split up and delineate roles in organizational code, as well as allow you to really get to the point of that not everything should live and managed by a single entity or single group. Again, we can author all sorts of different programs. This can be VMs, this can be block storage, it can be buckets, and this can even be Kubernetes clusters or all of the above. We can tackle many of the different layers in Kubernetes. We like to look at Kubernetes as a sequence of different layers that you can use. On the left, you see many different libraries that Pulumi has to work with the infrastructure providers, work with managed Kubernetes clusters or self-managed clusters. And then we have the Pulumi Kubernetes and Kubernetes X libraries that allow you to really work with the API resources or the API system in Kubernetes. That's everything from cluster services to application services to apps. With that, before I pass it off to Jay, I wanted to show you how we use Pulumi to really deploy the infrastructure that Jay will be consuming for his serverless demo. So as a brief overview, and I don't want to go into too much detail since this is Jay's forte, but Jay came to us and said, hey, it'd be great if you could set me up with the following resources. We stood up a cluster on GKE. We needed to use Knative, so we installed Istio. With that, we stood up Knative serving to do the serving of the serverless apps, eventing so we can act accordingly on events. Jay decided that he wants to use secrets managers from GCP, and Burgless is a tool that allows you to dynamically inject using a Kubernetes mutating webhook to alter the pod and inject the secrets from the secret manager. He also wanted to use Strimzy, which is a Kafka operator, and he wanted to deploy all of this using Tecton. This is kind of a visual of what everything's going to look like. We have a general managed cluster. Everything's going to be a set of namespaces. We're going to have a couple of these pieces being stood up. And let me just show you that really quick before I pass it off to Jay. So if I switch context here, I'm going to just run this up here for the sake of time. But here's my infrastructure that I stood up for Jay. And this time I chose to do it in TypeScript. So we did a demo in Python. Now let's see what it looks like in TypeScript. So you see, you import the same libraries, in this case from NPM. I stood up a GKE cluster. I had to configure a couple more properties since we essentially have to have the ability to allow pods for their service accounts to talk to GCP service accounts. So we have to integrate ourselves with the GKE metadata server to allow us to get the identity of pods and validate that. And at the same time, configure the cluster to work with Google's service accounts from Kubernetes service accounts. We can spin up an app namespace. So the namespace is going to be using. In this, you can see I've created my own classes. So this is where the power of code really comes and shines. I've created classes so you can hide the details of what actually is going underneath of these. So I'm going to deploy Burgless, which is a mutating webhook that I deploy as a GCP cloud function, and then create as a mutating webhook in Kubernetes that Jay will use. So that's one example of how you can leverage some cloud native resources. Then we're going to deploy a Strimzy Kafka operator in the cluster for Jay to consume, along with Istio and Knative based on the open source project. And I'm going to deploy Tecton last. So the application on the right is being stood up. This is going to take a couple more minutes, but before I kind of jump in, I want to show you kind of an example of what this looks like, right? So on Istio, here I created a class for, in this case, I'm deploying it from the YAML manifest. I can port those YAML manifests to a Helm chart, or if I want to do it in Pulumi native code, since I have the full API system available to me per this library. But in this case, I made it easier myself. I said, I'm just going to deploy the YAML manifest. So we can deploy YAML manifest. We can deploy Helm charts. We can deploy native resources directly in Pulumi. The same applies for how we do Knative. So we can install the operator CRDs, the serving component, and the eventing component. With secrets, the same kind of aspect is included in this, right? So I can create a GCP service account that will be bound to a Kubernetes service account. And because I have to mix and match all of these and reference this, especially I have to bind the pod to it, that pod allows me to essentially script this because I have code, right? Where I'm deploying here the GCP cloud function. If I scroll down, I then have to annotate anything with the mutating webhook that I create. So here I have the full mutating webhook API resource as you would expect it. Here's the service account that's been configured for Burglars to use. And here are the properties that they can and can't do with regards to the webhook. I will turn it over to Jay now.
Thank you. Oops. Thank you very much. That was very nice. I always like anything that kind of makes my life easier if I'm trying to use Kubernetes or any kind of technology. So I liked when I learned about Pulumi. Actually, I learned about it on a podcast, Kubernetes podcast. I want to say like 9 months ago, something to that effect. And yeah, it's been a pretty fun tool to play with. All right, let's get back to sharing here. Can everybody see my screen?
We got it. Thanks, Jay.
All right, cool. All right, so let's go continue on with this presentation then. So setting up the cluster for serverless apps. This is always a confusing thing for some people because when we say serverless, they have one idea, but then we talk about Kubernetes, which has nodes and everything. They have another idea, and they're trying to kind of combine what's serverless Kubernetes, and we're going to try to explain that. So anybody who's developed on Kubernetes probably have seen this many times or has experienced this many times. I'm trying to deploy an app. I'm trying to deploy a service, whatever, a backend function. I'm writing the code. Let's Dockerize it. And let's push it to wherever our registry is. Let's deploy said service. It exposes to the internet, set up monitoring, auto scaling, and that's just like a snippet of everything that's required. I have found that developers really only care about writing code. They will do the other functions because they have to, but usually they want to do what they are best at, and that is writing code. They just want to run their code. They also want to know that they can use whatever language dependencies they have. They don't want to feel like they're held back by specific opinionated systems where it says, well, we only support Python 3.6, sorry that you're using 3.7 for all your code, or finding some kind of backward compatibility, anything like that. And of course, as we mentioned, they don't want to manage infrastructure. Most developers I know, if they are managing VMs, they would rather not. They would rather focus that time on actually creating features. And you might be thinking, well, of course, this is something we've all heard before. This is the serverless model. We've all seen it. Everybody knows it. This is like from a developer's perspective. They don't want to deal with servers. They want to pay for usage. They want to know that their application is portable. And they want it to, of course, be event-driven because everything is event-based nowadays. And when I'm talking about this, well, a lot of people immediately think is they are thinking functions, functions as a service, your Lambdas, your cloud functions, so on and so forth. But really, serverless is more than just snippets of code. So yeah, when we think snippets of code, we're thinking of serverless compute, but there's serverless AI, there's serverless storage, where you're not configuring anything short of just saying, I want 100 gigabytes or 10 terabytes and that's it. You're not actually networking drives or anything. Data processing, serverless messaging, such as PubSub or a managed Kafka solution. There are a lot of things that could be serverless where you have effectively abstracted the infrastructure management away from the customer, and you have turned the pricing model to a pay per use versus a pay per provision, which is what we see with traditional managed tile services where you're paying for underlying workers. I usually break down the serverless model into 3 different components. There's the build, the deploy, and the consume. So I'm writing code. I have to build the code, put it into a package. I have to deploy it. I have to make it available to whoever the end user is, if it's an internal app, an external app, and then it has to be consumed. It has to be used. It has to do what it's meant to do. So we'll talk about little components that kind of fit each one of these buckets. So first, we're going to talk about Tecton. Tecton used to be kind of part of Knative, which we'll be talking about shortly, but because of all of it, the things that it had to offer, it didn't make sense to make it tied in specifically to Knative. It should exist as its own tool and be integrated into other tooling. So we do see like Jenkins X supports it today. Knative also supports it. Basically, it is a Kubernetes native component that allows you to create pipelines, and each pipeline has various steps. And then you're also able to create triggers for said pipelines. So I push something to GitHub, to my master branch. It will send a push event to my event trigger, which will then take the parameters in my event templates to go ahead and start creating the build process in a pipeline. Each step is its own container, and you can actually use things like Canico to actually build containers in cluster rather than having to use like Docker build or something. You can create logic if X is met, if Y is met, move to this step, move to that step. And also one necessary function that we see a lot of people are enjoying is the catalog. So while yes, you might have edge cases that are very specific to your use case, there are a lot of cases that are very common, like building, pushing to Kubernetes, pulling from GitHub. We actually have a catalog of reusable tasks and pipelines that you can pull in rather than having to reinvent the wheel every time. And of course, right now it's already integrated with Jenkins X, and we're seeing more people join the CD Foundation and start to integrate the tool into their own offerings as well. So we should be seeing more in the future. And it's really just a very great Kubernetes native way to deploy, to do your CI/CD pipelines and kind of your Kubernetes GitOps. And it actually lives on the cluster too, which is nice. So I know a lot of people are very security conscious and they don't like to have make calls outside of the cluster or outside of their environment in order to pull code. So having it all in cluster is a nice little benefit. So now we're going to move on from Tecton and talk a little bit about Knative. Knative isn't really so much of a product, so to speak, as much as it is the building blocks for you to build a serverless Kubernetes. So you might be thinking, well, what's serverless Kubernetes? Did we manage to get rid of node pools and node requirements? Well, no, but we're talking about the developer perspective. From the developer perspective, what it does is it abstracts the common tasks that you will see from the Kubernetes API and make it very simple for a user to deploy, auto scale, route traffic to their new service that they deploy. It's an abstraction on top of Kubernetes. It is not a replacement of Kubernetes. It is using Kubernetes objects and resources. So at the end of the day, it's running containers. Everything's a container. Everything's in a pod. Everything can be extended or integrated with other Kubernetes products. And of course, it's a fully open source product. But what is Knative not? It is not a Google product. Google did open source it back in 2018. But it is not an exclusive Google product. It is 100% open source. We do have a lot of developers, but we also have developers from other organizations that are contributing. And if anybody is interested in continuing to help us with this contribution, that would be great. And it is not functions as a service, which I want to reiterate for people who are familiar with thinking serverless equals functions as a service. It is not that. It gives you the tools to build that within your own environment or build a pass in your own environment. So if I'm the operator, if I'm the infrastructure manager using Pulumi to deploy my environment and manage the infrastructure, I want to enable my developers to do what they do better, I create a pass for them and make it easier to manage so they can handle their deployments without having to necessarily talk directly to the ops team. Knative is actually created of two components, but just to reiterate, developers can deploy directly on it. Operators can put a level of abstraction, and then of course your platform architects, your team that is actually building out the component can go ahead and create their own Heroku, App Engine, they're basically their own PaaS or fast system that could be used internally. So Knative serving is one of the two components, and the benefits of it is that it completely abstracts the deployment process for your end user. Instead of having to declare in the YAML a specific type of networking or having to create a service, open up node ports, anything like that, it actually will integrate Istio, but it also uses other service meshes, but Istio is kind of the native one. That's what it was originally built on, but we support, I believe, Glue as well, Ambassador, so on and so forth. You're able to deploy a container into Knative serving. Knative serving then intercepts the traffic. Any traffic calls that comes, Knative serving will then pick up said traffic and then route it to the proper container and spin up as many pods as necessary to accommodate the requests. Once no requests are going down, pods spin down to 0. And of course, in the nature of open source and Kubernetes and all things extensible, you're able to just swap out things with custom code. You're able to extend it. If you want to use your own logging platform that isn't the native one for Knative serving, you are welcome to. It is a fully extensible product tool. And let's look a little bit at some of the different components here. So auto scaling, if we're just talking native Kubernetes, memory, CPU based, with Knative serving, you can look at rapid request oriented auto scaling, handling traffic spikes. Scale to 0, Kubernetes doesn't really do that. The Knative serving operator, while that continues to run, it's what triggers the pod development. So if it's seeing no requests come through, it will run down to 0. Load balancing connection based, whereas this does its own, will do it based on the request, and you can actually do some cool traffic splitting. So if you want to do like a canary build and only let 2% out of the new version, you are able to do that. To kind of bring it home, I'm sure everybody here who's worked on Kubernetes or is learning Kubernetes has seen this. I want to develop a very simple hello world app, but I need to do two things. I need to create a deployment, and I need to create a service to expose that deployment. Is there a simpler way to do it? Well, Knative handles the replicating and the auto scaling, so I don't necessarily need to establish that. There's really no need to do labels and match those either. Let's see, we don't really need to, if we don't have to do it here, we don't necessarily need to do it in the service either. We don't need to necessarily expose the port. In fact, we can probably just simplify this. And here you see what an actual Knative fully functioning service on Knative looks like. So if I deploy this using Knative serving, this application will be exposed to the internet or internal within the cluster. You would be able to browse it and it would say hello world. And this is all you need to do to deploy it. So we have effectively eliminated a lot of the extra busy work, so to speak, combined the deployments and the service, simplified it, ready to expose beyond the internet. Developers love this. Now, what is eventing? So if we're going to try to simplify the actual deployment and management of software on Kubernetes for our developers using serverless, we have to simplify other parts. We are living in a data-driven world. We are living in an event-driven world. Everything that we do is almost real time, it seems like. If I am ordering a vehicle or ordering groceries online through Instacart or Uber Eats or whatever, you know, I'm looking at the phone and it's showing the car coming up and down the street, and I'm saying, okay, and you know, that's real time events being pinged. And a lot of people will, to deal with that, will use like a RabbitMQ, a PubSub, a Kafka, a lot of different tooling. The problem is when we're trying to build, when we are building microservices, these loosely connected, loosely bundled apps, loosely coupled apps and services, it becomes difficult to try to scale that out and manage that with multiple different services, trying to connect to multiple different buses and send events. So rather than having to imperatively bind them like we normally do, setting up libraries and connecting them and putting them into our code, using Knative eventing with simple YAML files, you're able to declaratively build the binds between services and the event sources in their syncs, or where the event is eventually supposed to go. And you can go scale from a few events, one that runs every 10 minutes, to live streams, which is by the second, millisecond, and also you can create existing pipelines to connect with your own existing systems, or you can create event pipelines, sorry, to connect with your own existing systems. So it's not meant to be exactly a full-on replacement, though you can, if you're not currently using some kind of eventing based system or message bus today, you can use Knative as that first class. But if you are using some legacy system such as Kafka or whatnot, you are able to hook back into that with Knative eventing and kind of get the best of both worlds. And here's just a very kind of brief overview of the two models we see with Knative. So you have the simple delivery. This is my event source, let's say a Kafka cluster, and this is my service. This is what, if we push an image and it hits the Kafka topic, we want it to run an API, Vision API against it. Very simple, unfortunately, or not unfortunately, but realistically, things aren't always that simple in the real world. Sometimes you need to put some advanced processing in there. You need to give you need to kind of give it some logic where if X parameters are met, then it should go to this service, so on and so forth. So we do allow for the concept of brokers in channels and subscriptions that kind of give you that additional pub sub model with topics and whatnot, so that you can then do that advanced routing when you have multiple services, which is kind of the benefit there, because now you're able to scale out same source, but now I'm able to add multiple services to that source. So a quick little diagram of what we have. So I use an API called AlphaVantage because, financial information is probably one of the best ideas or best examples of real-time data that I can think of. And they have a free API, or they have a free tier that's like 500 API calls a day, which is perfect for a demo. We have a concept called sync binding. What this is it will bind an event source to its sync. So we're able to do it within the YAML. We're using Strimzy, which to our CNCF friends is I believe it's still in the sandbox state, but it is a way to run Kafka within your Kubernetes cluster. We will have a Kafka producer sent to Kafka. We'll have a consumer, and then we will go ahead and take a look at the product. Serving is handling the traffic. Burgless is handling my API key. Tecton is installed, but we will not see it in this demo, but it will be there, I will assure you, when we show you the GitHub later. Let's do a quick demo here. So I created this cluster. This is I actually used the exact code that Mike showed earlier to create a cluster. And yeah, or not cluster one, that's a different one. I'm so creative at naming things. So this is your standard Kubernetes cluster. It has all of those services and workloads that we mentioned earlier. So I just jump in here and cluster, and let's see. So we have a lot of those workloads that we mentioned. We have these different tools or different workflows. We have the Istio gateway. We have the webhook. We have Istio. So yeah, this was all done with Pulumi. So I'm the ops guy. I've deployed it. Great. Developers, your turn to do things. So what I have here is, in this folder, I have a variety of different, I guess you can say, the different YAML manifests that will set things up. If we take a quick look at some of them, we have, actually we can just look in here. This is just as easy. We have the different currency sources. So here's the currency source. This is the application that is going to be pinging AlphaVantage. This is that Kubernetes service that I create. It's going to be using that Kubernetes container that we create as well. Event viewer, this is just going to throw things to the log. This declares a Kafka topic with Strimzy. This actually builds the Kafka cluster. Then of course we have what I call the Kafka consumer. This is what's going to read the Strimzy and send. So it will read this cluster and it will send the traffic to this event. Then we also have this is the service that is going to be producing sending the stuff to the Kafka cluster, publishing to the Kafka topic. Now, the sync binding is the interesting thing. This actually says, okay, that currency source that is pulling data from AlphaVantage, you will send it. This will be the source. This is the sync. This is where the data is going to go. So I don't actually have to directly connect these two services in any way. Knative eventing will do that for me. In kind of a real world example, oops, let me do that. There you go. All right, so what I will do is first I will delete the service that I have going right now. So and again, it's Kubernetes at the end of the day. So I just do like, if I can spell, at the end of the day, it's all Kubernetes. So let's see, currencies over here. All right, so I'll do kubectl, get ponds. All right, so it's kicking off the container. As we sit, we'll see that more containers will start to kick off. So currency source is now sending data to Kafka producer, so you can see where that kicked off. Kafka producer is sending it to Strimzy. The Kafka consumer is like, hey, there's traffic. And now it's sending to Event Viewer. What Event Viewer does is it collects the cloud events, which is a kind of a serverless spec for how to send events between different serverless products. Let's take a look at the logs here and see what we got. If I can, there we go. And so you can see here that this has actually given us the currency exchange for real time between Japanese yen and American US dollars. It's given it to us real time as soon as I push that app. And it's running every 30 seconds. Let's take a look. Yes, so I have this app. It's the currency source app. It's just running in pretty much an eternal loop for every 30 seconds and pulling the data and sending it over. So yeah, it's a pretty easy way with just YAML and not having to actually directly connect my files and declare that connection between the files. I'm able to use eventing as that abstraction layer so that I can connect applications without having to actually hard code it into the services themselves. And with that, I